Okay, question number 1. We have K is equal P R T. And we need to solve for T. So when we are going to solve for T, the T we are going to treat as an unknown variable, and P, R, and K are going to be treated as data that can be taken from somewhere. So to find T, let's say if I would have y is equal, let's say 3x. To find out x, what would I do? I would divide by 3 here. I would divide by 3 here, right? So whatever is acting as a coefficient for x would be divided by, right? Now, if we need to find the t from PRT, if t is going to be my variable, that means PR is going to be like coefficient, yes? So to find t, what am I going to do? I need to divide by P and R. And whatever change I do to one part of equation, I have to do to another part of equation. So which means I'm going to cancel this, I'm going to cancel this. And I will get the answer, which is going to be K. It's going to be equal, okay, hold on. T is going to be equal K over PR. Okay? Next one. Question number 2. We have L minus 9m is equal 17. So we need to solve for m. We need to solve for m. To solve for m, so what am I going to do? Negative 9m is equal. Moving 8L on the right side, so it's going to be 17 minus 8L. So if I'm solving for m, I need to divide by negative 9, right? Because coefficient of m is negative 9. So divide here by negative 9, which means divide here by negative 9, and divide here by negative 9. Correct? So this is going to be gone. There is nothing else to cancel, and I'm getting m is equal negative 17 over 9. So negative in the second fraction, it's going to be plus 8L over 9. Okay. So this is going to be answer, but we can write down in a better form since we have the same denominator. I write it 9, and I put the positive 8L first, and then negative 17 second. Nothing being changed by that, it's just a better writing. All right. Question number 3. We have P is equal 2M plus 2G. We need to solve for G. To solve for G, what am I going to do? I'm moving 2m on the left side, which will gonna be, and flipping the sign, obviously. P minus 2m. Remember, every time you move over equal sign, from left to right, from right to left, you flip the sign, is equal to G. Okay, so to get G, I'm going to divide by 2. And here, the whole thing dividing by 2. Actually, I'm going to divide separate. Why? Because I see on the top I have 2m. I can cancel these two. If I put this one whole fraction, I cannot cancel. Let me explain what I mean. If I have p minus 2m over, and this is common mistake. So you will never ever dare to cancel like that. Why is that? Because this 2 is a common denominator and for p and for 2m. So if you cancel 2 and 2, you leave this p without denominator, and the result is going to be p minus m, which is wrong. So if you want to cancel, say I saw 2 on the top, you want to separate them because it's common. I will get p over 2, let me put it wrong, p over 2 minus 2m over 2. See, denominator is the same, so I just separate it. This way, 2 and 2 will be gone, and the answer is going to be p over 2 minus m. You see the difference? Because if you cancel in this case, you take away the denominator for p, and that will give you a wrong answer or will take you straight to the woods. Okay, so we are canceling this 2 with 2, and I am getting, and this 2 also with this 2, and I'm getting p over 2 minus m, it's equal g. And that is going to be the answer. Next, or if you want to write down as one common the solution, like or, let me put this way. So if you want to write down p minus 2m over 2 equal g, then you do not cancel, you leave it the way it is. Either way. So, question number 4. T is equal BA minus 8, and we need to solve for B. So, to solve for B, I need to move this 8 on the left side. Will be T plus B is equal, oops, T plus 8, I meant, is equal BA. And I need B, so I'm dividing by A. I'm dividing the whole expression by A because there is no option for canceling or reducing. So this A is gone with this A, and the answer is going to be B is equal T plus 8 over A. All right? B is equal T plus 8 over 8. Next question, number 5. W is equal YR minus 3y k to power 4, solving for y. Okay, look here, we have y in two terms here, y here, y here. So what we're going to do? We're going to get as a common factor out, right? So w is equal, I'm taking y as a common factor out. I will have r minus 3k to power 4. And to get y by itself, what am I going to do? Divide the whole expression by r minus 3k to power 4. And here also dividing by r minus 3k to power 4. Because they are tied up with addition, with subtraction, r and 3k over 4, I do not dare to separate because here is multiplication. So I have to divide by either whole parentheses or I don't touch anything else. So this is I'm canceling and I'm getting y is equal w over r minus 3k to power 4. Next one, question number 6. T is equal m 7 plus f g, and we need to solve for f. Okay, to solve for f, what we are going to do, first I'm going to get rid of this m. So t is equal m times 7 plus f g. So let's divide by m, both parts of equation. This is gone, and I will have t over m is equal 7 plus fg. Next I have to get rid of 7. So it's going to be t over m minus 7 is equal fg, right? Okay, and next we are going to have find f, where I have to divide by g, right? Dividing by g because it's coefficient of f. Dividing by g. Here also dividing by g, and here also dividing by g. So what do we get? Let's see. T over m dividing by g is equal t over m. So if we have g, that means denominator is going to be 1, right? So when we divide fraction, what do? We flip the fraction, right? Second fraction times 1 over g. And the answer is going to be t over mg. So it's going to be the same way. So t over mg and minus 7 over g is equal f. So if we don't want to have two fractions here, I can bring to common denominator this mg and g. So in that case, what can I do? Let me rewrite. Can put or t over mg minus 7 over g, so is equal f. So I can bring to common denominator here. So mg and g, it's going to be mg common denominator, right? So which means here m, here also m. And that's going to give me mg and t minus 7m, and that will be equal f. So it's either going to be this or going to be this. Let me this one also make nice. Okay. This or that. Number 7. This one is easy. S is equal 7 pi x. So we need to find x. To find x, see now this shape is jumping out and okay. To find x, what do we have to do? Divide by how much? what will be if we want to find for x, everything else that's attached to x is going to be considered as a coefficient, which is going to be in this case 7 pi. Divide by 7 pi, divide by 7 pi. This is gone with this, and we have s over 7 pi is equal x. Next one. Question number 8. We have v is equal y a plus r. We need to solve for a. This is y. To solve for a, first we need to get rid of this y because it's a multiplication here. So what we are going to do, v is equal y a plus r, and we are going to divide by y, and here also by y. So this is gone, and we are getting v by y is equal a plus r. Next, to get a, we need to get rid of this r, correct? Moving on the left side. So when we have multiplication, then we have to divide to get rid of it. But when we have addition, then we have to subtract. If we have subtraction, we have to add. And if we have division, then we have to multiply. So we're always going to do opposite operation to get rid of this or that variable. Okay? V over y minus r is equal a. All right? And if we want to bring to common denominator, or we can write down the following way. V over y minus r is equal a. Bringing to same denominator, y. So divide here y, multiply here y. And I'm going to get v minus r y over y is equal a. Okay? So either this or that, these two. Same answer. So depends on situation. You might want to use either one format or another format. It's entirely up to you. Next one, question number 9. We have s is equal n over 3 times b plus h. We need to solve for h. So what do we have to do first? First we need to get rid of, since it's multiplication, we need to divide by n over 3, right? Get rid of n over 3. So let's do it. S is equal n over 3 b plus h. So let's divide by n over 3. Divide n over 3. So this n over 3 is gone with this n over 3. Now let's divide. Do drafting. Divide by n over 3. So this is going to be over 1, right? S. And from here we have s over 1 times 3 over n, right? We flipped it. And we get 3s over n. So we get 3s over n is equal b plus h. And from here we need to find h. It's going to be 3s over n minus b is equal h. And again, or if we want to bring to common denominator, it's going to be, it's supposed to be 3s. So, or I'm going to write down as a common denominator n. So it's going to be 3s over n minus b, n in denominator, n in numerator is equal h. So that is equal. You would wonder why I don't bring to common denominator entire equation, why I don't bring to common denominator h also. But keep in mind, I have already solved it. I have the answer here. This is the answer. All I am doing, I already have h. I don't need to get rid of h. I need to find out how much h is. It's just this left side expression. I'm just writing in two different formats. That's all. So this is going to be n 3s minus bn. So this is going to be second format. Okay, and this is first format, first one. So either this or that. Okay. Number 9. Let's go number 10. Let me clean this drafting. Question number 10. I have n is equal 3r g to power 4 minus 7rx. I need to solve for x. Okay, to solve for x, so since my x is in here, that means I need to get rid of a 3rg to 4, move on the other side, and that's going to give me n minus 3rg to power 4, and that's equal negative 7rx, yes? So since my x is my variable, so negative 7r is going to act as a coefficient, which means I have to divide by negative 7r. And whole thing, negative 7r. Okay, canceling here. And I'm getting n minus 3r g to power 4 over negative 7r. So I don't like to have fraction negative, which is this negative I can put right in the middle. Why is that? Because if you have negative fraction, let's say negative 7 over 4. It's going to be same thing, negative 7 over 4. It's going to be 7 over negative 4. It's the same thing. Why is that? Because this fractional line is meaning division. So, and if as long as one term is positive, one term is negative, in the case of division, you're going to get negative anyway. So it doesn't matter which one is negative, correct? For that very reason. So I put in the middle. And to get rid of negative sign, negative fraction, all I can do, flip, it will make it disappear. Remember, we treat negative sign in front of fraction as negative sign in front of parentheses, which means if I would have negative in front of parentheses n minus 3rq to power 4, if I open parentheses, I will have negative n plus 3rq g to power 4. This is g, sorry. So, and that's what I would get. And here I would write down, first I would write down just positive term, 3r g to power 4 minus n over 7r. Now, equal x. This is one format. Next format, I see I have here r on the top, r at the bottom. So if I want to get rid of r, what am I going to do? I'm going to separate these two terms in numerator, which means I'm going to write down 3r q to power 4 over 7r and minus n over 7r. See, I separated with using common denominator. Now I can cancel this r with this r, and I will get 3g to power 4 over 7 minus n over 7r is equal x. So this will be my next format of the answer. So both answers are correct. So it depends on the case. You can use either way. Question number 11. We have S is equal to 2HW plus 2HL plus 2WL. Okay, let's solve for W and then let's solve for L. First we are solving for W. Since we are solving for W and I have in two terms here and here W, so I want to get common factor out. So S is equal W taking out, I will have 2H plus 2L and plus 2HL. Now you would wonder why I didn't take these two also out, because I need W, I don't need 2W. That's why I need to solve for W. If I would have to simplify, then yes, I would. But I need to find out how much W is equal. So why would I drag 2 with W? Make sense? Okay, so next I'm going to get rid of 2HL, flip on the other side, which will be negative. S minus 2HL is equal W 2H plus 2L, right? And now to get W, what I have to do, I'm going to divide by 2H plus 2L. Here also 2H plus 2L. These two are gone, and my W is going to be equal S minus 2HL over 2H plus 2L. Okay, now in this formula I cannot cancel H under no circumstances, even if I would separate. Why? Let me show you. S minus 2HL over 2H plus 2L. Denominator is 2H plus 2L, so 2L I cannot separate from 2H. Therefore, it's going to be equal S over 2H plus 2L, and then minus 2HL over 2H plus 2L. Now you tell me, can I cancel these H's? No, because I have here another term attached to it, right? So, and here it is, I explained to you. Did I clean it? Yeah, I think I cleaned it. Okay, that's fine. Okay, so you cannot cancel any variable or any term unless that term is attached to another term by addition or subtraction. So, let me clean this. And next we are going to solve for L. To solve for L, what I'm going to do, I'm going to get rid of, oh, I have to combine L here. All right. S is equal to HW. Now, from this and this term, I'm going to take out L. So plus L taking out to H plus 2w. Okay? Next, I am flipping on the other side, 2hw. That's equal L times 2h plus 2w. And I'm dividing by, since I need L, I'm dividing by 2h plus 2w, right? 2h plus 2w. And this is what we get. L is equal S minus 2hw over 2h plus 2w. Okay. Question number 12. I'm going to do 15, 3 more. Now the last ones are becoming much more interesting. So I'm going to use formula for parallel connection of resistance in the circuit. And that formula is 1 over R1 okay, question number 12. So when you have circuit connecting parallel, the resistance, the formula, 1 over total R, and you want to find out the total resistance. Let's say you have this resistance. This is R1. You have this resistance. This is symbol of resistance. There has to be 3 of them. I put more. Okay, you can survive, right? 1, 2, 3. Okay. All right, let me do it. 1, 2, 3. And here is also 1, 2, 3. Okay. So, and we want to know if you connect parallel 3 resistance, 1, 2, 3, how much will be resistance on the output? Total resistance. So 1 over R, total resistance, it's going to be equal 1 over R1 plus 1 over R2 plus 1 over R3. And from here, let's say I know how much is the total resistance. I know how much is the resistance 1 and resistance 2. I need to find resistance 3. Is it legit question? Absolutely. R3 is equal question mark. How we are going to find out? Remember, using math, algebra, we are going to bring two, because we are dealing with fraction, we are going to bring 2 common denominator, correct? What is going to be here common denominator? God help us. We have R, R1, R2, R3. All that is going to be common denominator. Yes? Which means, so we're going to have 1 over R. So if let me write down here, common denominator, R, R1, R2, R3. So if I have R, I am missing here R1, R2, R3. Same thing here, R1, R2, R3. Next, equal. Here I have R1, so I am missing R1 I have. So I'm missing R, R2, R3. So here it's going to be 1 and then R, R2, R3. Yes? Okay. And then plus second one, I have R2, so I am missing R, R1, R3. Here is R, R2, R3. Okay, let me move this common denominator further. There we go. And then plus I have R free. So I'm missing what? R, R1, R2. R, R1, R2. Okay, let's check. Do we have the same denominator across the equation? Yes. So I'm dropping all this. And what do I have? I have R1, R2, R3 is equal R, R2, R3 plus R, R2, R3. Okay, something is wrong. I cannot have the same. So if it's R1, okay, R, R2, R3, I have, okay, this is going to be here. Hold on, this is going to be R1 because I have, 1 second, this is, I have R2, so I cannot have R2. It's going to be R1. See, I'm overlooked. Okay, R1. So, which means here also it's going to be R, R1. Yeah, I'm looking, I have identical term, cannot be. And then plus, I will have R, R1, and R2. Okay, we need to find R3. Where do we have R3? Right here, 1, 2, and 3. So I'm putting all on one side. It's going to be R1, R2, R3, minus R, R2, R3, minus R, R1, R3. All that is equal R times R1 and R2. Okay, I'm taking R3 out, and I will have R1, R2, minus R, R2, minus R, R1 is equal R, R1, R2. Okay, to find R3, what I'm going to do, I'm going to divide by this entire parenthesis. R1, R2 minus R, R2 minus R, R1. And same thing dividing here. R1, R2 minus R, R2 minus R, R1. Okay, this and this is gone. And I am getting R3 is equal R, R1, R2 over this entire expression R1, R2 minus R, R2 and minus R, R1. And here we got our answer. All right. So this is question number 12. Let's solve two more. So this was a formula for parallel connection of resistance. Next one, it's going to be area for the cylinder. 12. So we are solving problem 13. So A, area of cylinder, is equal formula for the cylinder here. With dashes, we are putting the lines that are not seen, right? That's why we are learning dashes in the graph. Okay, so it's equal area of the bottom, which is circle. It's area of it's 2 pi r squared because we have two bottoms. This is two circles, 1 and 2, right? Okay, it's supposed to be dashes. So therefore, it's going to be 2 pi r squared and plus this rectangle, right? Formula for rectangle is going, because we have two of them, it's going to be 2 pi r h. All right. So let's find out the height. H is equal question mark. So what we are doing, I'm moving 2 pi r squared, a minus 2 pi r squared is equal 2 pi r h, right? And to find h, I am going to divide by 2 pi r. So dividing here 2 pi r, this is gone, and I'm getting h is equal a minus 2 pi r squared over 2 pi r. And this is what we have. Or see, I have here 2 pi r squared, at the bottom 2 pi r. If you want to get simplify, separate them, it's going to be a over 2 pi r minus 2 pi r squared over 2 pi r, and that is equal h. So this 2 pi is gone with this 2 pi, squared gone with r. So I will have I over 2 pi r minus radius is equal h. This is also solution. So you have two of them. This is one. And this is another one. All right, and the very last one, formula for sphere. Formula for sphere. So, question number 14. This is, let me see if I can draw sphere. This is circle, and then here it's going to go like this. And not bad at all. Good job. Okay. And this is center, and this is going to be our radius, right? Okay. So, volume for sphere is equal 4 over 3 pi r cube. Let's assume we need to find the radius. We have volume. We know how much volume is, and we need to know which radius will provide us that much volume. Okay? So, first we need to find the radius cubed. V is equal 4 over 3 pi r cubed. So we need to divide, get rid of 4 over 3 pi, right? 4 over 3 pi. 4 over 3 pi. So this is gone with this. And I have V divided by 4 pi over 3. That is equal V times 3 over 4 pi. And that will be 3V over 4 pi is equal r cubed. But we don't need r cubed, we need only r. So what we are going to do here, making space. So what will be opposite to cube operation? If we have opposite to a squared operation is square root of a. And if we have r cubed, we are going to take cubic radical. So one r will come out. This one also cubic radical. So r, clean r will come out because I have 3 and 3. So this is r, clean comes out. And here it's going to be equal 3v over 4 pi. And here is radical, cubic radical. Okie dokie. I am done. Thank you for watching. And I'll see you in the next video.